Okay, now we can consider a very small, very easy operation between two matrices. Let's consider the matrix A, whose general element is Aij, and whose dimension is n by m, which means n rows and m columns. Then we have matrix B, which is given by a general element by Bij, and whose dimension is p times q. If you want to compute the sum of these two matrices, what is required is that the number of rows of matrix A is equal to be equal to the number of rows of matrix B, which is P, and the number of columns of matrix A must be equal to the number of columns of matrix B. If this is true, we can compute a matrix C equal to A plus B, whose general element is the element C, small Cij, and whose dimension is n by m, but n by m is equal to p times q, and the element Cij is equal to the sum of the corresponding elements of matrix A and matrix B, will be equal to Aij plus Bij. It's better to explain through an example, so consider a matrix A equal to 1, 2, 3, 1, and a matrix B equal to 4, 0, 2, 5. In this case, we can consider the matrix C equal to matrix A plus matrix B, because the number of rows of matrix A is 2 and the number of rows of matrix B is also 2, and yes, it's 2. The number of columns of matrix A is 2 and the number of columns of matrix B is also 2. So we can consider matrix 2 by 2. The first element is given by 1 plus 4, so it's 5. Then we have 2 plus 0, which is 2, 3 plus 2, which is 5, and 1 plus 5, which is 6. So it's very easy to compute the sum of two matrices A and B. It's not possible to, if we consider matrix D equal to, I don't know, 1, 2, minus 1, 3, 5, 7, it's not possible to compute, for instance, A plus D. Why? Because the number of rows of D is 3 and the number of rows of A is 2. So the dimension is not the same between D and A. We need to compute. It's not possible to compute the sum between these two matrices. Another very easy operation we can consider is the product of a scalar A and the matrix A. In this case, we get a matrix whose general element will be the scalar A multiplied by the general element of matrix Aij, and the dimension is the same of matrix A, so n rows and n column. For instance, we can consider the scalar A equal to 1/2 and matrix A equal to 2, 4, 6, 8. Very simple example. In this case, we can consider the product of the scalar A and matrix A, which is equal to a 2 by 2 matrix, because the dimension is the same of matrix A. The first element will be given by the product of 2 and 1/2, which is equal to 1. The second element will be equal to 4 multiplied by 1/2, which is equal to 2. Then we have 6 multiplied by 1/2, which is 3. and A multiplied again by 1/2, which is 4. Thus, this is the results of the product between the scalar 1/2 and the matrix A. We can introduce the difference between the two matrices at this point. So, if we have two matrices, A and B, we can compute A minus B, but also in this case the number of rows of matrix A must be equal to the number of rows of matrix B, and the number of columns of matrix A must be equal to the number of columns of matrix B. In order to compute this difference, what we have to do is to add to the matrix A the scalar minus 1 multiplied by B. So, for instance, if we consider the matrix A equal to 1, 2, 3, 1, and the matrix B equal to 4, 0, 2, 5, you can try to do it by yourself, but the difference between A and B is equal to a matrix with the same dimension of A and B, so 2 rows and 2 columns, and in this case, what we have to do, the first elements of our matrix will be 1 minus 4, or 1 minus 1 plus minus 1 multiplied by the first element, so 1 minus 4, which is minus 3, 2 minus 0, which is 2, 3 minus 2, which is 1, 1 minus 5, which is minus 4. So this is the results of this difference. A more complex operation is a product between two matrices. So let's consider matrix A, which is an n by n matrix, and the matrix B, which is an n by q matrix. This operation, the product, is possible when the number of columns of the first matrix in the product is equal to the number of rows of the second matrix in the column, in the operation. So the first thing we have to do is to check if the number of rows of the columns of matrix A, in this case, is equal to the number of columns of rows of matrix B. If this is true, we can compute the product, which is a matrix C with the general element Cij, with the number of rows of matrix A and the number of columns of matrix Q. This general element Cij will be defined as the sum for k equal to 1 until n. I remember n is the number of columns of matrix A, but is also the number of rows of matrix B. So we have to do the sum of A I k, B k j, and this represents each element of the product. In order to better understand this operation, let's consider two general matrices A with element A1, 1, A1, 2, and A2, 1, A2, 2. Then we have matrix B with element B1, 1, B1, 2, B1, 3. Then second row B2, 1, B2, 2, B2, 3. It's possible to compute the product A times B, yes, because the number of columns of matrix A is 2, and it's equal to the number of rows of the matrix B, which is also 2. We can see now that the product B times A it's not possible, because the number of columns of matrix B is 3, and the number of rows is of matrix A is different because it's equal to 2. So this operation is not possible. We can compute just A times B. A times B is our matrix. We can call C, and we have the elements C11, C12, C13, C21, C22, C23. We need to understand how to compute each one of each elements of matrix C. And we have to apply this formula. So for instance, what we need to do is to consider C11 equal to, we need to take under consideration the first row of matrix A and the first column of matrix B and apply this formula. So it will be equal to A11 times B11 plus A12 times B21. We get these elements. Again, we can compute the second element C12 considering the first row and the second column. So C12 it will be equal to A11 B12 plus A12 B22. Again, we can consider the element C1. It's better to write again the two matrices. So matrix A, which is equal to A11, A12, A21, A22, and matrix B, which is equal to B11, B12, B13, B21, B22, B23. Then we need to compute the matrix C, which is given by A times B, and the general elements are C11, C12, C13, C21, C22, C23, because the final product final results is a matrix of number of rows of matrix A and the number of columns of matrix B. So in order to compute this operation, what we can consider is C11 and C12 were just computed, so we need to consider C13, which will be equal to the first row, consider the first row and the third column, so it's A11 B13 plus A12 B23, and we get this element. So in order to consider the second row of the product, we need to skip to the second row in matrix A and again consider the first column in order to get C21, which is equal to A21 B11 plus A22 B21. Then, in order to get C22, we need to consider the second column, which will be equal to A21 B12 plus A22 B22. Finally, C23 will be equal to the second row and considering the third column of matrix B. So it will be equal to A21 multiplied by B13 plus A22 multiplied by B23. And now we can try to do an example.